Hello and welcome to the Boffin Buzz, the podcast for anyone fascinated by farming's future. Well, hello everyone and welcome to another episode of the Boffin Buzz. And today we're going to be talking soil science. What is going on beneath your feet in your crops is what we're going to be exploring today, and some really interesting science that we're going to be looking at with my very special guests. We have two guests today. Craig Sturrock from the University of Nottingham. Hello, Craig.
Hi, Tom.
And Emma Chapelhow from the UK Agri-Tech Centre. Hello, Emma.
Hiya.
Great. Well, now, one thing I really want to know, Craig, first of all, is key things that you would say are priority areas for UK farming. Three key things that you would say.
So I think the first one for me would be really farming practices that improve soil structure. To me, soil structure is really important for the health of the soil. So that would be my first one, and kind of a general appreciation of the importance of soil structure.
Okay.
Soil. The second one is probably more related to organic matter and maybe residue retention in soils, because that's what's going to be feeding all the biology that's in the soil that's going to actually impact on that first one, the soil structure. And then the third one for me is really a growing awareness of really on-farm trials. And this kind of ties into this new project that we're involved with you, Tom, called Truth, that we'll talk about more, I'm sure.
Absolutely. Well, as you can imagine, I'm absolutely thrilled by your suggestions there, Craig, because they tie in very neatly to everything that we're doing here at Boffin. But Emma, how would you, is there anything you'd like to add to what Craig said? Any sort of differences as far as you're concerned?
Yeah, so I think Craig's really summed up the soil focus one, and as a soil scientist myself, I'm completely on board with that. But I think building on the on-farm trials is soil scientists, we're looking at the system of soil, the interaction of the roots and the plant. One of the key elements in this system is the farmer. So bringing him in on the field trials, learning from them and working with them is really key to us understanding this whole system approach.
Fantastic. Well, that's great. Well, look, we'll delve into Truth and a bit more about soil science in a minute. But first of all, I'd like to know a little bit more about you. First of all, and starting with you, Craig. I mean, what led you into soil science? You know, what interests you? Is this something that you've always wanted to do, or is it something that's just happened by accident?
It's something that's happened, I guess, serendipity, maybe more than accident, but
right.
It's been a bit of a winding path, my movement into the kind of soil science area. I'm not a trained soil scientist in any way. I actually came in, although I grew up on a farm in kind of rural Angus in Scotland. My grandfather and my father kind of farmed a mixed arable, quite a small holding really. So we used to grow kind of barley, potatoes mainly, some turnips for kind of feeding cattle we had in the farm. But certainly it was pretty hard going for them. And when I left to home to go to university, I was going to do a biology degree because of the kind of I was interested in the kind of wider environment and kind of biology aspect rather than specifically farming. And I actually kind of vowed that I'd never work on a farm. And it's quite interesting now that I'm actually based on a farm here at Sutton Bonington at the University of Nottingham. So it's funny how sometimes your life actually kind of moves in a bit of a circle. But I think going through university, I had the experience of a whole range of different sort of aspects of biology, from like anatomy and physiology right through to more environmental sciences, a bit on microbial aspects of things. So it's quite diverse really. And in my PhD, I ended up working on fungal ecology. So I was really interested more in the kind of ecology side of things. And then after my PhD, I had the opportunity to work on a postdoc project that was looking specifically at sort of more soil health aspects. So we were looking at using different analytical techniques to quantify the health of soil. So we had some novel techniques. We were looking at like fungal biomass. We were looking at aspects of soil structure. And this was my first introduction into doing sort of soil science. And I was working with some pretty amazing soil experts at the time, and they're some kind of leading experts in the world
And
today.
that was at Nottingham, was it?
No, it was at University of Aberdeen in Dundee.
Right.
So I'd only moved. So I moved to this is my 14th year at University of Nottingham, but I actually moved away from this university in the UK across to Ireland to run some of these X-ray imaging systems that we have here in at University of Nottingham. So and then when I came back to Nottingham, it was kind of starting working with soils and working with Professor Sasha Mooney here. So yeah, it's been.
We'll delve a little bit more into the work that you're doing there in a minute, because I've seen it and I'm fascinated. But before we do, Emma, just give us some of your background. Your path to where you are now.
Yeah, really similarly, it's not a straight line to soil. Grew up in the farming community, spent my weekends earning pocket money, driving tractors, Young Farmers Club, and I actually went to university to study zoology, thinking I was going to become a journalist for National Geographic.
Right.
And then when I got to university and I joined the Agri Society and got back in with that community that I'd left from home, I realised that was the wrong decision, and very quickly shifted my degree back into agriculture and a bit more of a broadening understanding from a climate change and environmental point of view. And then came to the University of Nottingham for my master's.
Right.
I did my crop improvement, so looking at genetic modification of plants. So I'm still not in the soil at this point. And then finally, I went to do my PhD with Newcastle and Fairer Sciences. And it was in soil, and I'd never really looked at that before, but I've been really lucky that soil research started to accelerate, particularly the soil biology, as I was entering my PhD. So just landed on my feet, and I'm so glad that it's continued to be at the forefront of everyone's mind, because it means I'm getting such great opportunities to talk about my work and build it into the large agricultural systems.
So,
and now, go on, Tom.
Yeah, sorry, I was going to say, so you work now for the UK Agri-Tech Centre. How long have you been there? Formerly CHAP, I ought to say. Well, you tell me, because I know that there have been quite a few changes at the Agri-Tech Centre, haven't there?
Yes, so I joined CHAP 6 months ago, which was the Crop Health and Protection Centre. As of April the 1st of this year, the centres have merged together to become the UK Agri-Tech Centre. And so that's brought together Agri-Epi, which was the robotics, precision farming and machinery wing, CL, which was the livestock wing, and CHAP, which was the plant wing. Because there's so much crossover. And as we said, it's this whole system view. Like a farmer, he has tractors, he has plants, and he has sheep. So we have to have that whole view together, which is really important. And as I said, being part of the farming community has been something that's pushed me through the academics. And so that's why the UK Agri-Tech Centre is where I've positioned myself now, because we're really focused on getting this research and the data and the fantastic work Craig and the group do here at Nottingham to the farmers' hands and pushing agriculture forward.
Yeah, no, absolutely. Well, of course, we, all three of us, as in Boffin, University of Nottingham, and CHAP, along with John Innes Centre and PES Technologies, we're all partners in this new project, Truth, Thriving Roots Underpinning Total Soil Health. Before we sort of talk in more detail about that project, Craig, I want to come back to you and just ask you to describe, some of the work that you've been doing at Nottingham. I have to say, I've seen it myself, and the machines that you've got, these super machines that you've got. But would you just like to just talk us through some of the work that you're doing with Sasha there?
Yeah, sure, Tom. So yeah, I'm based at the Hounsfield facility at the Sutton Bonington campus at the University of Nottingham, and this is actually our 10th year of being open, and what we do here is we specialise on using X-ray imaging to look at soils and plant roots in soils. And this is a technique very similar to kind of medical CT scanner, but the configuration is slightly different, but it allows us basically to take a core of soil and see inside it completely non-destructively. So one of the benefits is we can basically measure the structure of the soil, so we can see where all the biopores are through that completely undisturbed without chopping it open. And also we can see where the roots are in the soil as well. So being able to pull out and decipher some of those interactions in real field soils is really quite amazing. And it's kind of mind-blowing. It's still like every day that I get a new soil core in, I'm kind of always get really excited to try and think, okay, what's this one going to be like? So
Yeah. No, absolutely. Well, I've seen it myself. I mean, so just to put everyone in the picture here, there are these quite large machines. I mean, it's literally it's like a CT scanner that you might get in a hospital or whatever. And if anyone's been in a CT scanner and seen the scans that you get from that, that's what you get. Now, what I love about what you're doing, Craig, is the imagery that you get from it. And I've seen these fantastic animations, literally of the soil core, where you strip away the soil and you can see the actual roots beneath it, and that is the actual picture of what your root is doing within the soil. Isn't that right?
That's right. Yeah. So the technique works really by the images that are created. We get a series of individual cross-section images through the sample that you've scanned, and the raw images are just sort of different colours of grey. We can sort of separate out the different materials based on those colours. So the roots will have one colour, the soil pores will have another colour, and the bulk soil will have another one. So in that very sort of simple three-phase system, you can kind of separate those three out. You can make them different colours to make them sort of pop out of the image, and you can visualise that in 3 dimensions and manipulate it. So
yeah. No, it's fascinating, and the animations that you get from it as well. And now, Emma, you're visiting the facility today, and have you seen the kit in action then?
Yeah, it's been eye-opening. So I've come from soil biology, DNA, and so this is my first interaction with kind of the physical imagery that we've been generating, and it's amazing the images we can see. And from the science point of view, we can see the aeration in the top 5 centimeters, and we started looking at some of the farms where we're getting compaction issues when we're hitting 10 centimeters, and you can see that, and you can see the story. But we also excitedly can see the roots meeting a stone and choosing to go around them and changing their thickness in response to what's happening in the soil, and you get to see that. Whereas everything I've done has been very destructive testing, taking the soil out, beating it within an inch of its life to try and get microorganisms out of it. And we did have a fun little go today following an earthworm through a core and seeing where that was going. So it was amazing to see. And I think it's so important when us working with farmers in the Truth Project, they can see these images and they can create a story from it.
Yes, no, absolutely. So just tell me, you've sort of hinted at it there, both of you, but could you just go into a little bit more detail, Craig, in terms of why is this actually useful for farmers, and why is this useful for soil scientists, and why is it useful for farmers to see these scans of their roots?
Yeah, so I think the first point, and it's the one that Emma just really hit the nail on the head there, is that traditionally the soil is really difficult to understand undisturbed. Most people will take a spade maybe and dig some of the soil out, and that destruction, all that soil structure that's a 3-dimensional structure falls apart when you start to do that. So being able to take a soil core or a block of soil and actually look at it completely undisturbed, you can see where all those connections are. And I think the other thing is that visual connection between what's going on in the soil core that you've got in front of you on the bench and actually those images, and making that relationship. So the importance of it is really that we can start to make measurements. We get all these really pretty pictures of where the burrows are and what the roots are, but because we can start to make measurements, we can look at, say, how connected all those soil pores are. How deep do they go into the soil profile? What's the size range? Are they all kind of quite kind of a certain size range, or in one orientation, or are there larger ones that kind of go more vertical rather than horizontal? With the roots, you can look at maybe how deep the roots go into the soil, what angle they go into, what happens when they interact with some of those biopores. Do they suddenly go down a biopore and access maybe water or nutrients that are deeper into that soil profile, rather than just going through the bulk soil itself? So the data is unbelievably rich. Like just from one soil core. You could sit there all afternoon going through it if you were kind of excited about soil as I am about some of these things. So.
No, absolutely. No, I can imagine. Now, just to give some background to the project here. So, this is a 3-year project. It's a £1 million DEFRA-funded project. As I say, that we're doing with the 5 of us partner organisations, and what we have just appointed 10 route rangers who are going through their fields. They've assigned a field where they're going to be doing some detailed soil analysis, and each of them are going to they are currently doing their soil analysis, and part of that is that they are taking 10 of these soil cores. So I'll ask you to describe exactly what we mean by a soil core in a minute, Craig. But they're taking 10 soil cores in a W shape across their field. They're also taking detailed soil samples, and the idea of that is that we're going to have a DNA analysis of those samples taken. And that's also to calibrate a sensor that's made by PES Technologies. This is a really clever sensor that we're looking at within the project that can smell the signature of a soil. So it smells the volatiles, and you can tell an awful lot from that what the microbial activity in your soil. So we're calibrating the sensor as part of the project. We're also looking in detail at the rhizosphere, the soil rhizosphere. So that's the sheath of soil right up against the root. And we're looking at what the nitrogen fertilizer does to the nitromonas bacteria. I think that's the right terminology in that area as well. Really fascinating project overall. But let's go back to the architecture, because that's what you're looking at in your lab. So, Craig, just give me an idea. Exactly what are we talking about when we talk about these soil cores? Can you just describe these for us?
Yeah, I should have maybe. I've got some in the lab just now, but they're roughly about the diameter of this coffee cup we've got here, but probably twice as long. So we're about kind of 8 centimetre diameter by maybe 15 centimetres long. And these are just sections of commercial drain pipe that we've sharpened up the bottom edge of them so that they're easier to cut into the soil. And we've made up these packs for the different route rangers. So there's 10 cores in the pack, and then there's also some sampling guidelines, protocols for doing this. And the route rangers will take these out to their fields and gently hammer them into the ground when the soil is a reasonable moisture level. If the soil's too dry and you hammer a core into it, you're just going to fracture all that beautiful structure that your soil naturally has. So that's the key thing, is really making sure that when the soil cores are getting collected, that the structure's been maintained as best as possible. Now, what's been really reassuring when we've been starting to get the first cores in and see some of these images, that this has been done really, really well. Most of the cores that have come in, there's very little disturbance from kind of sampling artifacts, shall we say. Right. Of course, there's 1 or 2 of the cores where we've looked at, especially in stony soils, when this is a bit more difficult, and you're just at your own luck, really, where you pick to take the soil core. If you hammer it in and it hits a massive rock or a large stone, it's going to impact on the structure. So we just have to make a little bit of allowances for that.
As far as I recall, the instructions we gave them were to place their core over an actual wheat plant within the field, so that they can capture, obviously a wheat plant. Is that right?
That's right. Yeah.
And the samples you're getting through, are they doing what they were instructed to do then?
I would say so. Yeah, they've been coming in, and they're really quite amazing. The quality of the images that have been coming in. Well, the quality of the cores that have been coming in, and we can see that in the images. So yeah, we've been able to see where the crown of the wheat plants, where all the roots are coming out. And as Emma said, when we were looking at some of the cores this morning, some of the ones where there are some of the stones in, you can see where the roots go down, hit that stone, and actually grow around the side of it. And they're really responding to that variable soil structure that you've got in the field that's made up of not only the biopores, but the larger mineral phases as well.
Great. Now, one thing I just want to emphasise there is, and I'd like to go over this again. So the cores that you've received so far, they've all followed the instructions. Have they? They've all been taken well. Just want to say, so there we are. Top marks to our route rangers. So well done them for doing that. And it's quite an important thing for us, Craig, because I'm sure we're going to touch on this later on. But there is a certain element of that farmers can't do on farm trials, that farmers can't do sampling and analysis and so on. I'm just wondering, maybe it's early days, but because I know that you had concerns over whether these samples were going to arrive with you in good condition. What are your thoughts as far as that's concerned?
As I say, that they have generally all they come in really good condition. I think so there's different factors that might impact on how the core might not be in optimal condition for measuring the root and soil structure. The first one is that disturbance element, taking the soil core when the soil's too dry and there's been a lot of force put into getting that soil core into the ground to get the soil out. It's just the soil's just going to fracture all up, and you're maybe going to break the roots. The biopores are all going to be disconnected. So any measurements that we're going to make on those cores aren't really kind of natural. What's going on in the farm, and that's what we want to be able to do. Obviously, the root rangers are all over the UK, so we've got that kind of geographical spread. So last week we had a box in from the Isle of Wight, and it's that worried they're getting shipped longer distances. You don't really know if your courier's dropped the box or if he's kind of kicked it off the back of the lorry or whatever. It's these little things that may happen, but so luckily they all look like they're pretty good condition. And obviously there's maybe a soil texture element to that as well. Most of the cores that would come in, they've been quite the heavier ones. They're quite clay soils, so they've been cohesively stuck together a bit better, and they're a bit more resilient for transport. So they've certainly benefited on it. So it'll be interesting when we get some of the root rangers that maybe got lighter soils. Are these in the same conditions? So it's all a bit of a learning experience, because this is the first time that we've worked on a project as big as this, of this type, and it's also quite a big project as well. So it's really exciting.
Yes. Yeah. So as you say, it'll be interesting to see once we go into the lighter soils whether, and also as things get drier as well. It has to be said, we took quite a lot of care at Boffin to make sure that the farmers were given all the packaging materials and so on, and we thought very carefully about how they should package it, send it back, and things like that. So it's good to hear that the samples are coming through really well, and hopefully we'll get some good data from it. Just want to turn to you, Emma. So you've seen some of the samples coming through. Is there what sort of impressions are you getting? Are you learning anything from this? Anything that you didn't perhaps hadn't seen before?
Yeah, so I think the practices that we've been advocating farmers take up, so minimum till, ploughing, and things like that, it's really interesting to see the impact they're having. So we looked at 2 different farms today, one from the Isle of Wight that was really porous, we could see all the holes, and it kind of went the whole way throughout the core. But then we looked at one that had been scanned the day before, and we're seeing real compaction when we start hitting that 10 centimetre kind of line, and we've got different farming practices there. So to me, seeing such a pronounced change between 2 cores is amazing. When we're looking at biology, which is where I've been, and metabarcoding, and that's an element of the Truth Project that we are starting to look at, the resolution for the data is so minute that it's really hard to tell any differences being caused by management practices, because bacteria and fungi are everywhere, but how active are they? Who's there, who's not there? It's really hard to see, but these images really allow us to go, there's a solid line there where these practices aren't making a difference. There's a solid compaction there. there's loads of rocks there, there's a worm there. It's real, visually you can see a story of what's going on that's not clouded by millions and millions of reads, which is what we kind of see in soil biology and how to pull stories from. So I've been really excited today seeing the impact the farmers have been having on their soils from changing these practices.
Yeah, now you touched just there, Craig, on the size of the project, and I just wondered. I mean, we're sending in. It'll be over 100. No, it'll be almost exactly 100 soil cores this year. And, I mean, and this is only the first year of a 3-year project. It's going to be 200 soil cores. No, at least 200. It's probably going to be more like 300 next year. You'll have your work cut out for you, by the way. And then a similar number in year 3. So, I mean, is that more cores than you've had in on a project before? How does this stack up in terms of, sort of project ambition?
It's certainly one of the largest projects I've worked on. We had a previous PhD student that worked on a large number of farms across the East Midlands, but I think it was maybe not so many soil cores at each farm, so it maybe balances out. But certainly over the 3 years, having that over 30 farmers involved in this is going to be a really large data set. And I think what's exciting that the work that we're doing here in Nottingham is only one of the measurements, really. It's when we start to pull together all these other different measurements that not only PES are doing, but also JIC, we're going to have this really amazing data set, and not to forget about any of the measurements that the farmers are making themselves. So when we bring all that together, it's going to be really exciting to see what's...
And I know this is very early days, Craig, and you've only had a few of the samples through, but is there anything that you can say at this very early stage about what you're learning from some of the samples that you're seeing, some of the variances that you're saying? I mean, Emma was talking just a minute ago about how the compaction is so obvious from the soil cores. But is there anything that you're finding that is really sort of standing out as an interesting finding, even at this very early stage?
That's the main one, I think. It's the difference when you look at these images, there's almost like a cross section through that core, just that one impression through it, and you can see by the amount of biopores that you've got distributed through the depth of that core. Now, certainly the cores that we're looking from the Isle of Wight, we've got nice, quite large earthworm-related probably biopores that go from the soil surface all the way down to the bottom of the core, that full 15 centimetres. Whereas compared to some of the other ones, we've certainly got one down in Kent, I think, and also down Herefordshire, that there was maybe they weren't quite like that. We're maybe only sort of either halfway or kind of about 3 or 4 centimetres down. But there's a lot of variation. There's, some of those other sites have maybe got more stones. The soil texture is slightly different as well. So there will be other factors, but we've really just had a quick scratch of the surface. As I say, the core's only really been stick-and last week. So by the time you get the next boxes in, and we can build up that kind of database of information on the different properties of these soil cores. But yeah.
And just sort of turning to the root architecture itself. I mean, first of all, it'd be interesting to know. I mean, and you mentioned just now, Emma, that it looked as though the roots were sort of finding their way around stones, obviously. But are they reacting to a compacted area of soil as well? I mean, is there a big difference in architecture, noticeable difference between a compacted soil and a sort of more aerated soil? Are you seeing that in the samples, Emma?
I don't think I've noticed it yet, and we were quite focused on the pores this morning and using the great software Craig's got that pulls out the area of the pores as opposed to completely following the roots. Especially also, we're relatively early on in the wheat growth, aren't we? We've not quite hit the deeper roots. So I think as we get more soil cores in later on in time, we might start seeing that. I don't know if Craig's had a much more in-depth look than me. I was following earthworms and things like that.
I think I totally agree with that. Really, it's very early days. Like, I think you needed time to start visually screening through these and get a feeling for, okay, well, these ones, it does look like there's only biopores at the top, and it looks like it's more compacted at the bottom. Now, what are the roots doing there? And we can start having a look through that and trying to understand the overall structure that's both with the soil and with the roots in there. So, yeah, we hope that'll obviously come in the next few weeks to months.
Right. I mean, is there, you know, I mean, we know that there are some simple things that farmers can do to help their soil structure. But from your experience looking at these soil cores, I mean, what really makes the difference here, Craig? Is it earthworm burrows? Is it you know, how much they've disturbed their soil? Are there any sort of differences, you know, in your experience, not necessarily just from these samples, but perhaps samples in general? You know, that things that farmers, you know, the obvious things that farmers can do that really make a difference when you're actually looking at the soil structure. Are there things that stand out in terms of a management perspective?
So I think it's very much sort of site-specific elements. So it's difficult for me just to give you an answer on kind of blanket. All farmers must do this because of it's going to improve the structure. I don't think that answer is really available. It's going to be very much dependent on the local conditions, what the soil texture is within the farm, how it's been managed previously, what the crop rotations are. There's going to be a lot in there. But I think there certainly does seem to be some nice relationships between, say, the biology that's in the soil and that building the soil structure, especially kind of things like deeper biopores at depth. So elements that may contribute to that is maybe not ploughing the soil up so much, so that there's more earthworms populations there, different types of earthworms as well, different species. Certainly the cores that we've been looking at, there seems to be a lot of sort of one species of earthworm that are maybe slightly thinner, that are kind of moving around the soil surface, and then some of these sort of deeper ones. So I'm not an earthworm biologist telling you which species is which, but certainly they seem to work in different actions.
Just thinking there, you know, presumably you've got, you know, they're live soil cores. They've probably still got the earthworms living in them.
Well,
so you've actually seen earthworms within the thing. I mean, is that does it hurt the earthworm at all, by the way, to go through the CT scanner? I suppose it's no different from you or I going through a CT scanner and having our brain scanned. So hopefully it doesn't. But is it? You might even have an earthworm that would actually move halfway through doing the scanning. So that might look a bit weird as well. Have you got live earthworms in?
We've got some examples of that. Yeah. There's also other things in there as well. There's been some regions where there's other sort of burrowing insect in the soil that they've almost like made a little sort of dormancy structure, a little sort of cave in the soil almost, that they're sitting holed up in there, and you can see the difference in their outline. Obviously, we can go into the images and we can actually pull out some of those 3D structures, but I mean, that's why the technique is so interesting, because often you say, going back to that idea, if you take a spade, you dig up your soil and you kind of maybe shake it, and it breaks up all that structure, and you can see sometimes some of those larger insect larvae and things jumping out, but being able to see them in situ in the soil is really interesting.
Yeah, no, well, that's fascinating. I must say, you know, we're going to learn so much about the work that you're doing with these soil cores. And of course, one thing I should mention, by the way, is that another element of what we're doing is looking at the soil mycorrhizal fungi as well, the arbuscular mycorrhizal fungi. So our root rangers are also taking samples that are going to be analysed, root samples, so that we can analyse the AMF activity in the soil as well. And as you say, Craig, that will all build up into a really nice picture of what's going on with our soils. But I wanted to move to the next thing that you touched on earlier, which is about organic matter in the soil and building organic matter. Do you want to just tell us a little bit more about why this is a priority?
So I see this as really, it's almost like the food for the biology in the soil. So the amount of organic material that you're retaining in the soil, that's what's going to be feeding all the microbes in there, the fungi. So then you've got this sort of giant food web of they're going to impact on this sort of larger sort of macroinvertebrates, so the kind of the earthworms and other burrowing insect larvae and thing that's in the soil. So these are providing that food source to them. So by increasing the amount of food that you've got in that system, you're also going to increase the amount of biology that's going to get an impact back on the structure. And as they break down the carbon sources that you've got there, they're going to be releasing nutrients that's going to be beneficial to your plants as well. You've obviously, if you're not ploughing up every year and you're leaving the plant roots in there, they're going to degrade over time and break down and release kind of nutrients back to the soil that the next crop's going to be able to capitalise on.
It's a fascinating area, this really, isn't it? And I don't know, so your background, Emma, in what you've done, how much you've looked into this as well. But I get the impression that we are only just touching the tip of the iceberg of how much we understand about, soil carbon and the role of organic matter and so on. Because, we talk very glibly about soil carbon and things, but actually it's a hugely complex area, isn't it? And it's made up of so many different creatures and aspects of it. I don't know, sort of what your impressions are, Emma, of this area.
So I work quite a lot in this area, and I was actually at an event on Friday that I'm going to do a quick shout out for, the Soil Academy, which is aimed at farmers to understand their soils a lot more and this influence with carbon. And a lot of the language that's being used around soil carbon is just like, you want more of it. But they were talking a lot more that there's a whole ecosystem and process behind that. So you have to have the right carbon to nitrogen ratios to get your microbiome kick-started before it can even begin to start to digest this organic matter and then lock in more carbon. So we're only beginning to understand that life cycle of carbon fixing into our soils. So it's really interesting. And as I said, this whole systems approach, it's the organic matter, it's the microbiomes, it's the crop. And you did ask Craig earlier about what he thinks a good kind of recommendation for farmers to be. And I've been involved in quite a few conversations recently about leaving the crops in longer than you would normally if you can afford to. And it's all about this idea of, if it's bigger on the outside and above soil, you're giving it more of a chance to grow under the soil as well. So you're giving the roots the time to do their jobs, you're giving the microbiome a chance to do its job before cutting it off short. So some fantastic conversations going on around this.
Yes, of course, because there is this sort of debate going on about, what is carbon in the soil and how you can influence it. And as far as I gather, it's about active carbon. One of the aspects is how much active carbon is in the soil. And I think, people tend to dismiss the active carbon as in the living carbon, because obviously, it lives and then it dies. But if you can encourage more activity in your soil, then that activity will build, and that will actually build the overall total level of carbon. So let's take very worse soil, which is effectively a dead soil where you've got very little microbial activity. That's naturally going to have very little soil carbon because there's very little life in it. It's the life that gives it the carbon. But as you build that activity, then it's sort of kind of self-generating. And yes, okay, so obviously the microbes, they're living and then they're dying, and as they die, they let off CO2. But if you're increasing that activity, then you are increasing your soil carbon, by its very definition. So it's really, really important that we understand these aspects. Isn't that right?
Yeah, this new understanding of the carbon life cycle, which is hard to imagine because we don't think carbon's alive. And as you said, that's the microbiomes. They lock in some carbon, they die, they technically release some, but they're kickstarting that ecosystem and this circularity, which allows us to constantly build more and more carbon and build a healthier soil. So the practices farmers are doing are not necessarily locking carbon in, they're making a better life cycle for carbon.
Right. Yeah. In terms of the work that you're doing, Craig, how what sort of aspects of the work that you're doing are looking in more detail at this particular area of soil carbon?
So we've got a few projects that are looking at the impact of different tillage practices on the soil, and as part of that, we're also measuring organic carbon and greenhouse gas emissions in it. So it's kind of measuring this, taking a range of different measurements of that soil system and kind of studying them all together. I think I was going to add from that last comment. It was really about thinking about the time element, like how long things take to develop. It's not often maybe a quick fix. Things where we're seeing carbon building up, or the impact of any of these sort of practices on the generation of soil structure. It can be quite a long process, and certainly feeding back into actual productivity. So a lot of the research that's been done on the positive benefits of certainly reduced tillage seems to be taking 10, 15 years to start getting big differences. So I think it's always good to kind of keep that at the forefront of the mind as well, that it's a long-term investment, but hopefully the benefit is lifelong after that.
Yeah, no, and I hope that's one thing that's going to come out of this project, because we've obviously got a whole range of farmers involved in this, right from, so we've got one or two organic farmers, we've got a lot of regen farmers taking part, and some conventional farmers as well, perhaps people who are just at the start of their no-till journey. And that's one thing that we found in a project that we were involved in, Boffin. This was an AMF. We were looking at the AMF in soil with the Crop Science Centre. And we had, across the country, we had 40 samples that were sent in by farmers. And this was the interesting thing that we found, that the range of AMF within those soils was massive. It was staggering, much greater than Tom Thurkel, the scientist who was involved, thought there was going to be. He reckoned it would be in about the 20 to 40% band from these arable soils, and it actually went from 5% to 69% AMF root colonization. So it'll be interesting to see what the samples turn out like from the samples that he takes across our samples of soil this year. But I'm conscious of time, and it's a fascinating conversation. I mean, soil is always a fascinating area. There's always so much to talk about. But did want to talk about the last aspect that you touched on earlier on, Craig, which was on-farm trials. Obviously, that is what Boffin is all about. So I'm so pleased that you've highlighted that as a priority area. But for you, why is this a priority?
I think there's an aspect that comes back to probably an earlier soil project when I started working in this area, and we weren't working with agricultural soils, we were working with golf courses, and it was looking at the soil using the CT scanners to look at the structure under golf course greens. Now, obviously, these are very intensively managed systems, but the person that knows most about how to generate that structure is the greenskeeper themselves. So I think taking it back, starting working in agricultural setting, there's so much knowledge there and understanding of their own systems from the farmers themselves. So where you've got an engagement with the farmers and the scientists together, and you're kind of almost like co-creating these sort of trials and using the different techniques that obviously a CT scanner is not generally available on every farm or at all. So able to sort of the farmers to have access to the latest cutting edge technologies, but with their own understanding of their system as well. And it's bringing together, I think, the different techniques and knowledge levels at different areas that's really quite exciting, and hopefully it's beneficial to sort of better understanding of the systems and also improving agriculture in the future.
Yeah, no. Can I turn to you, Emma? I mean, this is obviously. I have to say, by the way, we're involved in, I think it's 3 projects now with UK Agri-Tech Centre. All of them have obviously got on-farm trials at their centre. It's great to see on-farm trials now take such a prominent activity in these research projects. But from your point of view, and perhaps the point of view of Agri-Tech Centre, I mean, why is it important that farmers get involved in research at this level?
Yeah, so ultimately the Agri-Tech Centre is there to accelerate adoption of this research or technologies, and it's much harder to get the end user and the farmer in this case to adopt new practices if they've not been brought in early on. Their opinions and their knowledge on this is so valuable, so getting them involved early on, understanding what's going on makes it a lot easier. It's the difference between a company that builds up your trust and works with you and takes your reviews to the door-to-door salesman trying to sell you a hoover you've never heard of before. So it's really important we get their buy-in really early on. But I'm also just such a fan of what farmers know, and they know their soils better than anyone. Like when I first started doing research, I knocked on the farmer's door with all my science kit and thought I knew everything. And as I've aged and worked more and more, I've learned to just listen to what they're saying, and they're so important. And the root rangers we've got involved are so enthusiastic. It leads to the success of these projects.
I think that's an interesting actually point. I think because I'm thinking of the images that we're generating. Like me and Emma can sit in front of these images and go, "Oh wow, look, there's all these biopores here." But when we actually, I think the beauty for this, we can actually give back all these images to the farmers, and for them to be able to sit down and say, okay, well, what we're seeing here is because I know that I've done this to the previous crop, and it's getting their insight into the interpretation of this as well. That's going to be it's really valuable.
No, absolutely, and that's a really important part of the project that we're doing with Truth, and actually all of the projects that Boffin is involved in. So, but specifically on the Truth project, our root rangers, so they're being paid to take part in these on-farm trials. We were oversubscribed. We were lucky to have many more farmers wanting to be root rangers than we had positions for. But as you say, we've got a really enthusiastic bunch and a really nice cross-spread across the country, across soil types and farming systems and so on. So we are very lucky with the root rangers that we've got. But one of the very important parts of their job is to relay what they see to farmers, and you made a very important point there, Craig, that not every farmer, it's quite an expensive job, this soil coring thing, isn't it? So it's not something that every farmer could afford, let alone have access to the equipment that these farmers have got access to. But that's a very important part of it, that we're going to be relating what they see in the field with their roots and so on to some quick and easy measurements that they can take in the field. And we're going to be developing that as the course of the project goes on. So that, and their role within this, the root ranger's role, is going to be relaying this information about what they're seeing to other farmers as well. So other farmers will be able to listen to this. And just before I move on at all, I just want to mention the Soil Circle, which is our community, our online community. This is on the Farming Forum. If you go onto the Farming Forum and look for the Knowledge in Farming area, and then within that, there is the Soil Circle, where the discussion is just getting underway with our root rangers and our project partners on Truth. And there are one or two interesting conversations already taking place there. All of our root rangers are bringing their experiences, they're discussing them. So please do join the Soil Circle. If you go to truthproject.uk, so that's truthproject.uk, that's our website where you can join up and join the Soil Circle and then take part in the discussion that's going there on the Soil Circle. So do take part. Anyone can take part. It's absolutely free, no obligation at all. And we will be looking for more root rangers to be taking part next year. So we've only got 10 root rangers at the moment. We are hoping to expand it up to 30 next year. So that's going to be quite a bold ambition. And we are looking, only apply if you're one of the best farmers in the country, obviously. But that's where we're looking for. And yes, so we will be looking shortly for new root rangers to be taking part in the project as it goes forward. But look, I've been blabbering on about Truth, but just to return to what we're talking about, and we need to sort of draw it to a close, really, Craig and Emma. And I just wondered, I was looking for your thoughts on where all this is going. I mean, we're setting out to do some really worthy things here. Actually, it has to be said. With what we're doing with truth, we've talked about sort of structure, organic matter, carbon, and so on, and the role of on-farm trials. But where is this going? What's your ambition, Craig? In terms of where you think this should be leading us?
Yeah, I think. Well, as I say, I think it's really powerful, this approach that we're taking, when we're kind of bringing together not only the expertise of the farmers but also the scientists together. And I think it's a really interesting way of kind of moving forward, obviously to develop and get these insights into different farming practices for the future. So it's more maybe like that. It's maybe changing the way how we would do things in the future, rather than people being in their own little silos. Like the scientists work in one place, the farmers do one thing, and maybe the scientists telling the farmers to do something, but then when they try it on the farm, it just doesn't work at all, and there isn't really that connection between them. But I think it's important to always remember that there are multiple ways of doing things. So it's good to have, like, I don't know, it's like that. You've got multiple tools in your toolbox and be able to access them for the right situations. Also to keep in mind as well.
Yeah, no, absolutely. What about yourself, Emma? Is there anything to add to that, do you think?
Yeah, I think Craig really summed it up there. The fact that there's so many people involved in this project and bringing all of that knowledge together, and it comes back to that systems approach, whether we're talking the system approach in the soil, linking the microbiome to the structure, to us linking the farmers to the soils, to the farmers to the wider community. It's really important we have the system approach, and truth is really utilising that and bringing the scientists, the farmers, and eventually industry into what we're doing.
Absolutely. Well, I mean, collaboration is absolutely our centre ground. That's exactly what we're aiming to do with this. So it's really good to hear that. And that's exactly what we're aiming to do with this project. Very much farmer-led, backed by science, but it's a collaboration of farmers, scientists, and industry. And it's specifically looking at the soil. It's going to be such a fascinating project. I have to say, I've enjoyed it very much so far, and I'm really looking forward to finding out what we're going to find out over the next 2.5 years. So it's going to be a great journey. Anyway, listen, that's all we've got time for. Thank you very much, both of you, for coming on and for sharing your experience, your knowledge, and what you found on the Truth Project so far. I'm sure we'll be coming back to hear more. And as I say, please do join the Soil Circle and take a look at the discussion, what's going on. It's the Soil Circle, which is where we're going to be putting the results first. And so, if this is an area, if your soils, soil science is something that interests you, and let's face it, every farmer should be interested in soil science, then please do join the Soil Circle, keep an eye on there, and join in the discussion as well, see what's going on. Ask a question, and we'll make sure that a scientist comes back to you with an answer. So, well, listen, thank you very much, both of you, for joining us. And thank you, all of you, for joining us and listening to the Boffin Buzz. So, and without further ado, we shall see you again very soon on the Boffin Buzz. Goodbye.